Adding and subtracting fractions. Adding and subtracting fractions is easy if you already have the same denominator. Why do we need the same denominator? Here we have 1 over 12 plus 5 over 12. We would like to add these fractions together. Remember that 1 over 12 means that we have 12 equal pieces and we've shaded one of those equal pieces. 5 over 12 means that we have 12 equal pieces and we're shading 5 of those. The idea is how many equal pieces have we shaded? So there's a total of 6 of these exact same size equal pieces. So what we do is we're saying there's 6 out of those 12 equal pieces now that we have shaded. What is 6 out of 12 the same thing as? We see that 6 out of 12 is half of the circle that has been shaded, so that would be the same thing as if I reduce this to a fraction of 1/2. So it's important that we have equal pieces, equal sized pieces, so that when we add, so we say 1 out of 12 plus 5 out of 12, what we're actually saying is that we have equal pieces. How many of those equal pieces do we have? Well, we have 6 of those 12 equal pieces that we've shaded, and we always want to reduce. Let's add and subtract these fractions. We have 4 out of 9 pieces plus 1 out of 9 pieces. Since the denominators are the same, all of the pieces are the same size. So we have 9 equal pieces, 9 equal pieces. 4 plus 1, we know that's going to be 5 out of those 9 equal pieces. So we add the numerators together, keep the 9. That's telling me how many equal pieces that I have broken up my whole into. Here we're subtracting, but we have the same denominator, so 1 out of 6 equal pieces minus 5 out of 6 equal pieces. We subtract. 1 minus 5 is negative 4, keeping our denominator of 6. We want to reduce this, breaking up into prime factors, canceling our common factors. We end up with a final reduced answer of negative 2/3. Part C, we have 9 out of 14 size equal pieces plus 12 out of 14 equal pieces. We will add our numerators together. 9 plus 12 gives me 21. All over the same size pieces, 14. We want to reduce. We'll break 21 into primes. It's 3 times 7. 14 is 2 times 7. We will cancel out our common factors of 7, and we end up with a final answer of 3 over 2. We always want to reduce our fractions. What if our denominators are not the same? Here we run into a problem because we have 3 out of 4 equal pieces. So if I shade 3 out of 4 plus 2 out of 3 equal pieces, the problem is that the pieces are not in the same size, they're not in the same denomination. This is 1/4, 1/4, 1/4, 1/4. This is 1/3, 1/3, 1/3. The pieces are not the same size. So how many pieces can I say? Well, I can't say I have 6 or 5 of, well, I don't know. I don't know how many equal pieces that we have overall. So what we need to do is find a common denominator. In other words, if I was to break both of these up into smaller pieces, how many would it take for them to have the same size pieces? Let's say that I would take this and I would break this into 3 pieces. So each of these be broken up into 3 pieces. Pretend like those are equal. And the same thing over here. Let's say that I break this up into 4 pieces. Now both of them have 12 equal pieces. The way that we're going to do this is that I can change a fraction by multiplying by 1. If you think about it, remember we said 3 over 3 would be the same thing as 1. That gives me 9 out of 12. So what I actually have shaded is 1, 2, 3, 4, 5, 6, 7, 8, 9 out of 12, where all the pieces now are the same size, 1/12 each. On this side, I'm going to multiply by 4 on the top and the bottom. I'm not changing the value of the fraction because I am multiplying by 4 over 4, which is the same as 1. And now I have 8 over 12. And that's saying I have 1, 2, 3, 4, 5, 6, 7, 8 size pieces out of the 12. Equal size pieces out of the 12. So how many total equal size pieces do I have? Well, now I can see that I have 9 from the first one, and from the second one we have 8. So 1, 2, 3, 4, 5, 6, 7, 8. So all together we can see that we have 17 out of those 12 equal size pieces. So we have to have the same denominator, which means both fractions have to be broken up in the same number of equal pieces so that we can say that we have 17 out of those 12 equal sized pieces. "12" is actually what we would call the least common multiple of 4 and 3. Least means smallest. When I look at the numbers, the multiples of 4 and the multiples of 3, when I look for the numbers that they have in common, 12 is the smallest multiple that they have in common. They also have 24 in common, but we want the smallest value that they have in common, the smallest multiple. We also call this the lowest common denominator. When working with fractions, we want to find the least common multiple of the denominators. Is the smallest number that both denominators can become by multiplying. We usually call this number the lowest common denominator. So you want to multiply the top and the bottom of both fractions so that we achieve the same denominator. There's another way that we can do this without drawing pictures. We can factor both denominator into its prime factors. So earlier we did 3 over 4 plus 2/3. Let's use a new method to find how to add these fractions together. To find the LCD, we can we can break up our denominators into prime factors. 4 is actually 2 times 2, and 3, of course, is already prime. It's 3. The second thing we want to do is multiply into the denominators the missing factors. We just want to make both of these denominators match. So for example, over here we have a 2 and a 2. What is this one missing that the second fraction has? Well, the second fraction has a 3, so I will multiply the top and the bottom of this fraction by 3. The second fraction, when I look at its denominator, it is missing 2 and 2. So I will multiply in the missing factors. And that's basically the same thing as 4, so I'll multiply top and the bottom by 4. Now you notice that both of my denominators now all have the same exact prime factors. They both have a 3, they both have a 2, and they both have a 2. My LCD is, once they match, my LCD is taking those numbers, multiplying them together, and we arrive at 12. Now we want to look at our new fractions. That would be 9 over 12, 8 over 12. Keeping the same denominator, we know that we have 17 out of 12 equal pieces. So we multiply in the missing factors into our denominators. Whatever I multiply times the bottom, I have to multiply times the top to make our denominators look the same. Find the lowest common denominator and then subtract the fractions. To find the lowest common denominator, we first want to break our denominators up into primes. Let's take 42 and let's make a little factor tree. 42, any two numbers that multiply together to give you 42. I'll say 6 and 7. 7 is prime. 6 is 2 and 3, and both of those are prime. So we have 2 times 3 times 7. Now let's do the same thing with 30. 30 would be 2 and 15. I'll keep the 2 since that is prime. And 15 can be broken up into 3 and 5. So we have the prime factors of 2, 3, and 5. Now we like to multiply in the missing factors. Our first denominator has 2, 3, and 7. What is this one missing that this one has? Well, this one has a 5. So let's multiply in a 5. I'm going to multiply that missing factor times the top and the bottom of our original fraction as well. And what is our second denominator missing that the first one has? Well, it's missing a factor of 7. So I'm going to multiply in this missing factor times the top and the bottom of our original fraction. Now we notice that our denominators both match. They all have the same exact factors, 2, 3, 5, and 7. And this turns out to be 210. So our LCD would be 210. Now let's find out what our new fractions are, our new equivalent fractions. Top would be 45 over 210 minus 77 over 210. So these are our new equivalent fractions. Now we want to actually combine them together. We will keep the same denominator of 210, and we will subtract 45 minus 77. You're going to do larger minus the smaller. In the answer, it will keep the sign of the larger value. Now we do notice that both of these numbers are even, so I do want to reduce this fraction. 32, we can make a factor tree for that. That would break up into 5 2's multiplied together, and 210. Now we know what factors are in 210 because we just multiplied all that together to get 210. It's 2, a 3, a 5, and a 7. So what can we cancel out that's common? Well, they both have a common factor of 2, and it looks like that is all that they have in common. So our final answer will be negative. Let's multiply all of these 2's together. 2 times 2 times 2 times 2 would be 16, divided by, and then we have 3 times 5 times 2, which would be 105. That would be our fraction that is to its lowest terms, our reduced fraction. Okay, our denominators are a little bit smaller, but we still want to subtract. 13 over 8 minus 7 over 12. We want to find out what our lowest common denominator is. Let's break up 8 into prime factors. 8 would be 2 and 4. Keep our 2. 4 would be another 2 and 2. And 12. 3 times 4. Keep the 3 because it's prime, and then 4 breaks up as 2 and 2. Now we have the prime factors of both of our denominators. Now what we want to do is look at the first denominator and see what it is missing that the second fraction has. The second denominator has a 3 in it, so we'll go ahead and multiply in a 3. And we'll do that times the bottom and top of the original fraction. Now what is the second fraction missing? What is that second denominator missing that the first one has? Well, we notice that this one has a 2, an extra 2 that this one doesn't have. So we'll go ahead and multiply in that extra 2. Now when I look at my denominators, we see that they all have exactly the same factors. Everything matches. So our LCD would be taking all of those matching factors and multiplying them together, and we get 24 as our LCD. So let's find our new fractions. We have 3 times 13, which is 39. 3 times 8, which is 24. Minus 2 times 7, which is 14, divided by 24. We'll keep our LCD of 24. 39 minus 14. And we get a positive 25. And that is already reduced to lowest terms. Alright, we want to find the LCD of these two fractions and then add the fractions together. So let's take 24, break it up into prime factors. The first thing I thought of was 3 and 8. It doesn't matter where you start, we'll all end up at the same place. Just keep breaking it up into its prime factors until you can't go any further. So 24 is 2 times 2 times 2 times 3, 18, 3 and 6, and then 6 breaks up as 2 and 3. So that's 2 times 3 times 3. Multiplying our missing factors. This one here is missing an extra 3. So multiply top and the bottom by 3. This one is missing 2 2's. So the first one had 3 2's. This one needs to also have 3 2's, which is the same thing as multiplying by 4. So our new fractions would be 33. 3 times 24. Multiply that together here on the side. That would be 12, carry the 1, that would give me 72. So 33 over 72 plus 4 over 72. Remember, our LCD here is taking all of those factors and multiplying them together. That would be the same thing as 8 times 9, which is 72. Add our fractions together, keep our same denominator, combine our numerators on top. 33 plus 4 would be 37. And that is already reduced to lowest terms. Our last one here, we have two values we want to add together, 3 plus 7/8. In order to add these together, if something doesn't look like a fraction, then we would make it look like a fraction by putting it over 1. And we can clearly see that our LCD at this point would be 8. You multiply top and the bottom here of this fraction by 8. 24 over 8 plus, and this one could stay exactly the same, 7 over 8. Now they have the same denominator. We're going to keep that same denominator and combine our two numerators together. 24 plus 7 would be 31. And that is already reduced to lowest terms.